So it is well known that gravity can extend for millions and billions of miles. And it's also known that the distance that gravity is felt is related to the mass. So now we can understand this again with gravity strings. More mass will have more gravity strings. A greater density of gravity strings closer together. When they're close enough together, remember these are wispy strings. They're floating through the air like this. They will eventually merge because they're so close and create a longer string. And the way to think about this is the cars on a freeway. If you have a 3-lane freeway and 50 cars, it's a nice short distance. But you close the left lane, you close the right lane, what's going to happen to all those 50 cars? They're going to have to go somewhere. And they'll go several hundred feet ahead. Same thing with the gravity. Right? So we had gravitational energy units in each one of these strings. But now that they've been forced to merge together, it's going to be a much longer string. And if you have more of these strings that merge together, it'll extend miles. Even more strings, millions of miles. Even more strings, billions of miles. It's all just a matter of the energy strings flowing together, compressed together, and then making that straight line forward. It also shows something else. Because even though gravitational energy goes for millions of miles away from the Earth and the Sun, it's weak. You can put, for example, an artificial satellite, several million miles away from a planet. It'll feel some gravitational pull, but not a lot. And again, why is that? You don't have 1,000 gravity strings at a distance of 1,000,000 miles. What you have is merged gravity strings making only 1 or 2 strings at millions of miles. Therefore, it's only this little satellite is only going to feel 1 or 2 strings and not the hundreds of thousands down here. So again, this subtle concept of gravitational energy and distance can be explained by simple gravity strings. This model can explain everything. There's nothing that this model can't explain. When I first came up with this model, it only took me about 2 days to come up with the entire thing. That was it, 2 days. And then I spent the next couple days going through several tests. Every single gravitational observation I can think of. Someone walking on the moon, the boulder falling down the cliff, the Earth going around the sun, a whole bunch of different things. And every single one is correct. Even the Einstein's general theory of relativity. This is a more advanced concept, but he uses bending of light to prove his theory. I can explain it with gravity strings. He talks about redshift. His understanding of redshift is totally wrong. That'd be another presentation, but I got to clearly understand redshift, which makes a lot more sense. And part of it uses gravity strings. So this can explain pretty much anything and everything. Well, that concludes my presentation discussion for today. I'm very glad that you guys were here. I'm very glad that you guys got to see all these different models. And, well, I hope this model, I know this model is correct, and I just can't wait to see it grow and develop as people begin to embrace it and see what it has to offer. Okay, thank you.